Good afternoon. My name is Riikka Venesjärvi and I come from the Natural Resources Institute Finland. Today I will talk about valuation of marine ecosystems, and the work that I will present here has been done in SmartSea project at the University of Helsinki, University of California and Natural Resources Institute Finland. And I will talk about different aspects of valuation. First, Blue Growth is an initiative to further harness the potential of Europe's oceans, seas, coasts for job value and sustainability. However, various anthropogenic pressures have caused severe biodiversity loss and habitat fragmentation. Loss of this biological diversity, it alters the functioning of ecosystems and their ability to provide society with the goods and benefits that we need to prosper. Marine spatial planning can be seen as a solution, and it can be a process that implements risk-averse ecosystem-based management into practice and enables integrated, forward-looking and consistent decision-making. The aim of the marine spatial planning is to choose an option that will minimize the ecological and socio-economic risks and costs and maximize the benefits and public acceptance of a use of these natural resources. In ecosystem valuation, our aim is to assess the links between ecosystem processes, functions, services, benefits and human actions, and estimate how these benefits and values provided by marine ecosystem vary when the state of an ecosystem changes. Here we have different approaches. In the middle we have monetary ecosystem service assessment that is only one part of this valuation. And in monetary ecosystem service, and if we add effort benefit assessment, we estimate the total economic value that can, and where we utilize the use value and the non-use value of ecosystems. Then we can have different quantitative ecosystem service assessment methods, and finally we can have comprehensive study of human-nature interaction. And in this picture I have examples of cultural ecosystem services which are located in the different places. And examples about these different methods. This direct monetary quantification, it can mean, for example, the study of expenditures for consumption of services, travel cost method and hedonic price method. This indirect monetary quantification, it means, for example, contingent valuation, a willingness to pay, and choice experiment methods. Then we have non-monetary quantification. Here we can use, for example, preference values, scenic beauty model, choice experiment, again, visitor numbers, pulse and heart rates of these visitors, and psychometric scales. And then finally, in this qualitative description, we can utilize participant observation, action research, semi and unstructured interviews, field notes, group discussions and analysis of documents. So we can value different kind of things using different kind of methods. Natural sciences alone cannot provide an adequate basis for the management of these complex environmental problems. Our aim is to integrate ecological knowledge with information about human drivers that are analyzed with economic and social sciences and combine these ecological and socio-economic values in marine ecosystem in a one working framework. Today we have heard a lot about these different kind of drivers. In our work, we estimate the effects of these different pressures to the state of an ecosystem. Then we decide how we estimate this change. So we use different kind of indicators, for example, and with that we can study what kind of impacts these pressures have on human well-being in order to know what kind of responses we need to carry out. So this is our framework or the method that we have used. So we have used Bayesian networks here. And our modeling framework supports decision analysis of marine spatial planning scenarios, and our aim is to assist in sustainable growth in the marine sector as a whole. And this is a simplified version of the model, but it describes you the framework and the problem. So first, we perform a probabilistic risk analysis to estimate the adverse effects of human pressures on marine ecosystem. So here you can, for example, see different kind of pressures that are caused these different human actions. And then we have these different nodes that are these environmental parameters explaining the predicted occurrence of these fish nursery grounds. And here we have a submodel that estimates the predicted the effect of these pressures to the predicted total biomass. Then we generalize our model to an influence diagram by including these utility functions, which are here. For example, here we value the biodiversity value of these fish nursery grounds, and here we have a cultural, but it's titled cultural benefit, but we have estimate this willingness to pay information that public they have valued that what their willingness to pay to avoid these harmful changes in the ecological status of coastal waters. And based on these obtained results, we perform a decision analysis between the demand for marine resources and safeguarding these ecosystem services and benefits. And in future, when these research outputs or new observations become available, the flexibility of these Bayesian networks, this used methodology permits the model to be updated to represent the latest comprehensive knowledge on this matter. And also, if the information is available, these utilities can be expressed in monetary terms, allowing the Bayesian network to compare the trade-offs quantitatively under different management options and to calculate the monetary value of reducing the certainty in our ecosystem-based management plans. In this case, we used benefit transfer to estimate the value of change in environmental quality. And the benefit transfer is a good method in transforming prior knowledge to develop an estimate. And evaluating these trade-offs of alternative decisions requires estimates of the costs and benefits of their different outcomes. And here we can use marginal analysis, that is a mathematical technique for analyzing choices and studies, and it studies the impacts of these little adjustments. And we can also do this via ratios, even if we don't have a numeraire good. And please notice that we can have uncertainty here. So uncertainty over these losses may cause the planner in marine spatial planning to optimally delay these actions until we have the better information. And the decision support model should include information about uncertainties related to these decision options, as the certainty of the desired outcome may be central criterion on the selection of these management plans. And the definition of these conditions We need to define these conditions when it is optimal to delay or postpone these decisions for finite duration. For example, we can use quasi-option value, and that describes the amount the people are willing to pay to have an irreplaceable resource preserved until we have better information. And this could be applied when we're talking about, for example, these geological deposits. And this value of a resource provides justification for applying these precautionary actions. In addition, we can also use value of information, and that helps us to find the most critical uncertainties from a decision-making point of view, and then we can also estimate that how much we would have to spend time or effort to reduce these uncertainties. So this was just a short description of this valuation and our work. So if you have any questions or want to know more about this, you can email me, and if you're brave enough, you can even call me, or you can also tweet your questions. Thank you.
Thank you, Riikka.